Hello everyone. In this video we will talk about equilibrium of a particle. A particle is in equilibrium stage when the sum of the forces acting on this particle equals to zero. Now let's say a spring is applying a force on a particle. A spring originally has a length L0 shown here, and after the force is being applied the new length is L, so we have an elongation S. So the force applied by the spring is going to equal to Ks, where K is the spring constant and S is the elongation. Now we can get S by simply doing the final length minus the original length. And also a body of a mass m has a weight which will be mg times g, where g is the gravitational acceleration, and as Ig is simply 9.8 meters per second squared. Now moving on, in a coplanar system xy, for a particle to be in equilibrium, the sum of the forces in x and the sum of the forces in y has to equal 0. Now let's do a small example about this. Let's say a body with a mass 60 kilograms has a tension here T and another T1 over here and T2 over here. Now let's draw the free body diagram of this body. So we have basically the weight acting on it and the tension. Now if we do the sum of the forces in the y direction on this body, basically the weight equals tension, and this is gonna have to be mg, which we already know. So now we have T. Now if we do the sum of the forces in y on this particle over here, we know T1y plus T2y equals T, and T1y is basically T1 sine 45 plus T2 sine 30 equals T, and we have T. And the same in the x direction equals to 0, so T1 cosine 45 equals T2 cosine 30. Now this is a system of two equations, two unknown. We can easily solve for T1 and for T2. Next we'll talk about three-dimensional system. It's basically the same as a coplanar, except now we have a new axis, z, so the sum of the forces in x, y, and z have to equal 0 for the particle to be in equilibrium. Now if we do a very quick small example about this, let's say a body with mass m, 60 kilograms, has the weight here, and let's say it has an F2 in the direction shown here, 30 degrees from the x-axis. That means, and it's in this plane, xz plane, so it'll be 60 degrees here, and another force F1 in the yz plane, sorry, and oh no, sorry, this is in the yx plane, and it's theta from the y plane. Now let's say we want to find what F1 is and what F2 is. Now already we know the weight is mg, which is 60 times 9.8. And now if we do the sum of the forces in the y direction, we know that this is equal to 0. Now we can right away see that the only force acting in the y direction is F1y. And we don't know theta, so if F1y equals 0, we don't have a force in the y direction, so theta equals 0. The next step is to do sum of the forces in the z direction equal to 0. So we know the weight, mg, this is the weight, is going to equal to F2y, which is F2 sine 30. And now we can solve for F2. After we solve for F2, we can do the sum of the forces in the x direction equals 0. So F2 cosine 30 equals F1. And now we have F1. So this basically sums the force equilibrium. Of course, we're going to be using it later on in future chapters. This is kind of an introduction of the chapter. Thank you very much.